1B on Thursday, the 8th of October. Students will be able to graph parallel and perpendicular lines, section 4.7. That's the symbol for parallel. That's the symbol for perpendicular, by the way. So we're going to talk about parallel lines. Parallel lines are lines that are in the same plane and do not intersect. They're in the same plane and they don't intersect. Meaning they never touch, okay? Ever, ever, ever. Now we have a symbol for parallel. Like I said, you can either do like two straight up and down lines, kind of like two ones next to each other. Or more commonly, much more commonly, we'll see these two slashes. Where do we see parallel lines in the world?
The road.
The road, right? Like the two lanes on the road. Okay, those are going to be parallel. They better not intersect, okay? Where else can we see parallel lines? Okay, Tucker? Railroad tracks, okay? They better not intersect either, okay? That'd be really bad. Okay? Where else do we see parallel lines? Maybe even in this room. What? Math, okay? Where else do we see them? Aiden? What?
The box.
The box? What box?
The integrity doing right thing.
Okay, poster. So like right here we see parallel lines, or like maybe here. Okay? Where else do we see them? The desks are in parallel lines. Okay, where else do we see parallel lines? Well, maybe stripes on a flag, lines on a wall, in the ceiling, okay, in the carpet. Do we really see them just about everywhere?
Yeah.
It's crazy, isn't it? Yeah, right here on the bookshelf, okay? So many things are parallel. You would never ever want those to touch, ever, even if they continued on, so that you wouldn't want them to touch. Parallel lines have the same exact slope. They have the same exact slope. Now let's think about that for a second. If they weren't parallel, if they did not have the same slope, would they eventually touch? If one line was going, don't draw this. If one line was going like this, and another line was going like this, would they eventually touch?
Yes.
Yeah. And even though they have pretty close to the same slope, it's because they don't have the same slope. But if they have the exact same slope, then they'll never, ever, ever touch. Okay? So parallel lines have to have the same slope, because if they're different, then they're going to be at a different angle, and they'll eventually touch. Even if you don't see it happen, they'll eventually touch. Okay, like the example on the left. So all vertical lines, show me which way with your hands vertical is. Okay, vertical is this way. All vertical lines, think of a vertical jump. Okay, all vertical lines are parallel because they have undefined slopes. Remember that V kind of looks like a U, okay? They have undefined slopes. So they're all the same. They're just all undefined. And vertical lines would never touch each other, right? Horizontal lines are parallel because they all have slopes of what? What's a horizontal slope? Okay, horizontal is this way. Zero. What's the second letter in horizontal? Oh, and it kind of looks like a zero. Okay? Now what we're going to try and do is we're going to try and graph a line through negative 2, 4. That's parallel to the line y equals 1/3 x minus 3. So we have this line y equals 1x, 1/2 x, or 1/3 x minus 3. Well, what's the slope of that line? 1/3. What's the b of that line? Negative 3. And we would begin with b. And so if we don't graph this line. But if we were to graph this line, it would look like this, right? Up 1 to the right 3, or down 1 to the left 3. And it'd go through here. Now we know we want our new line to be parallel to that, right? But we want it to go through this point, negative 2, 4. Does this line currently go through negative 2, 4? No. Okay, we want it to go through this point, clear up here, and it currently doesn't. We want it to be parallel. Well, here's what we can do. Okay? Here is what we can do. We can take the slope of 1/3, and what do we know about the line that's parallel to it? What will that slope be? Parallel lines have what kind of slope? The same slope. So if the orange line has a slope of 1/3, what's our new line going to have? A slope of 1/3, because it's supposed to be parallel. It has to be the same slope. Aiden. Is that what? No.
North, south.
I don't know my north, south, east.
Right now?
I don't know.
That's south.
You have a compass.
That's south.
You have to be kind of more that direction right now.
No. North that way.
South. Neptune's that way?
North's that way.
Yeah. North is this way right now.
Go that way.
No.
So it has a slope of 1/3, and we know it has that point. So can we graph this point and then use that slope to make a new point? Can we graph that point and use this negative 2 comma 4 as our starting point instead of the b? Could we go up 1 to the right 3 and down 1 to the left 3
Yeah.
and make a line?
Yeah. Parallel. Boom.
And now they're parallel. Now so we have a line that's parallel to our orange line. The y equals 1/3 x minus 3. But now it goes through negative 2 comma 4. See what we did there?
You just switch it.
What?
Huh?
You literally just do the same thing.
We use this point to start with because we know this point's on it. The whole reason we begin with B is because we know B is going to be a point on the graph. We don't really care what point we start with. As long as we have a point to start with, you can use slope to go to any other point on the graph. Just like if I was on the orange line, if I started down here at this point, I could use the slope and go up 1 to the right 3, and I could get back to my original point.
So you just graph that thing and then follow that rule.
Yeah, you graph this point, and you use this slope because parallel lines have the same slope,
Got it.
and we want it to be parallel.
Got it.
Okay?
Please be quiet.
What?
Please be quiet.
Okay? Questions on that? Let's try another one of those. Okay? Let's try another one of those. Graph a line through 1 comma negative 2 that is parallel to the line with the equation 3x minus y equals negative 2. So what's our first point going to be that we're going to have on the graph? Okay, not just negative 2, but on our new graph. We don't need to graph the orange thing here every time. I just did that to show you, okay, what it would look like that they would be parallel. We only really needed to graph what was in the pink. So what would be our starting point for the line we need to graph? 1 comma negative 2. Very good. This is our starting point. One to the right, negative 2 down. Now we know it needs to be parallel to the line with the equation 3x minus y equals negative 2. So if it's parallel, what do we know about those two lines? They're going to have the same slope. So we need the slope of this line, 3x minus y equals negative 2, so we can make more points, right? Because if we have the slope, we can use it to go to new points. Up however many, over however many, down however many, over however many. But do we know the slope of that equation right now? No, why not? Y isn't by itself. Very good, Lainey. We need y to be by itself, so it's in y equals mx plus b form. So how can I get y by itself in 3x minus y equals negative 2? Okay, I'm going to subtract 3x. Very good, Lainey. You're nailing it. Negative y equals, would we rather have the negative 2 or the negative 3x first? Negative 3x first. Very good, Reagan. Because that's how our y equals mx plus b goes. You have the x first. Okay, is y completely by itself yet? No, what's secretly with it?
1.
A negative 1. So how do I get rid of that?
Put it over negative.
Divide every single thing by negative 1. Y equals what? 3x plus 2. So now, how does this help me?
X is 3.
The slope is 3. So what's our slope of our parallel line? Our parallel slope. See how I put M for slope, and then I put the little parallel symbol? What's our parallel slope going to be? 3 or 3 over 1. So now, where do I go from my point 1 comma negative 2 to get a new point?
Up 3 and right 1.
Up 3, right 1. Or where else can I go from my original point?
Down.
Down 3, left 1. I can do the opposite. Man, you guys are nailing this. Like, seriously. If Mrs. Springer was in here right now, she'd be like, stupid proud of y'all. Just saying. Okay. What part don't you get? Any of it?
Yeah, I don't know.
Okay. Well, let's back up a second. I want you all to get it. Does anyone else not get it? Give me a thumbs up if you're feeling good about it. Thumbs down if you're not. I want you to be honest. Okay? A thumbs aside was not an option. Give me a thumbs up if you get it. And if you don't get it, give me a thumbs down. That was not an option. A thumbs up is an option. A thumbs down is an option. Okay? Well, if you don't get it, then it's not a thumbs up. Okay? All right. Let's talk about this one, okay? Once again, just a recap, not a no cap, but a recap, okay?
Cap.
Parallel lines do not intersect.
That's not what I'm confused about.
Okay. Well, you said you didn't know, so I wasn't sure.
So, here,
Yep.
B, what is that? Like, yes,
Okay.
negative? Never mind.
No.
No, I got it.
You actually do?
Yeah, I really do. I really do.
Okay.
Oh, no, I do.
Does it smell in here, guys? I might smell
no,
it.
I get it. You can even do one. I can
Okay. We're going to talk about perpendicular lines now. So let's flip the page.
Whoa, you flipped it too fast.
Uh-oh, he flipped it too small for her. Don't flip it too fast, please.
Hold on.
Yeah, I need to hold on.
Keep holding.
Hold up. Good job, Mr. Castle. Hold
Holding.
it in the air.
I'm holding up and holding on.
Got it. You're good.
Drop it.
Let-
You can
I was told to,
Don't.
I was told to hang on.
Not kick it. You can stop hanging on.
Okay.
That would be a bad
Okay.
That's not drop kicking it,
Drop
though.
kick it.
You acted like you were going to do it.
All right. That's true. Perpendicular lines. So we have parallel and perpendicular. We have three types of intersections, or three types of lines. We have lines that intersect like normal. We have lines that are parallel, so they never intersect. And we have lines that are perpendicular. Perpendicular lines are lines that intersect at right angles. What's a right angle? 90 degrees, okay? It makes it rounded off or squared off, okay?
Did we actually just do that?
It's a 90-degree angle, okay?
We went.
Yeah, it's pretty great. And they mirrored each other. It's pretty cool. Okay, we have a symbol for perpendicular as well. It looks like an upside down T.
Oh.
Did it go the other way?
Nope,
Oh, wow.
Because then
Okay.
it would be 11.
because then it'd be a T,
Oh.
and that'd get confusing.
Why can't
It
it
would
be a
be-
T?
Because then if you write a T, everyone's gonna think it's a T, but not
See?
instead of perpendicular.
Ah.
Now here's the thing. Here's how the symbol comes from. That would be like two perpendicular lines, right?
I feel like 4.
Okay. No, this line is perpendicular. This would be like 4 right angles.
Yeah.
But it'd be two perpendicular lines because they create the right angles. But if I write like this, does that kind of look like something else we see in math?
Plus sign.
Kind of looks like a plus sign.
Yeah.
So that's why we kind of erase that part, and boom, we have the perpendicular symbol.
Why can't we just put the arrows on it so it doesn't...
If you want to keep drawing arrows all the time, I guess you could, but that seems like a lot of work to me. Okay. Yes. Okay. The slopes of perpendicular lines are opposite. What does it mean to be opposite of something? Different, but they're like the entire different, right? So if something's positive, what's opposite of that?
Negative.
If it's negative, it's positive, okay? So the opposite sign, and it might be even good to write like in parentheses down here, positive and negative. So that way we remember it's the signs, okay? And it's also the reciprocal. What's the reciprocal, guys?
It flips.
The flipped fraction. So maybe it'd be helpful to write a little reciprocal here. 2 over 1 and 1 over 2. That way you guys can remember which one's which. So they're opposite reciprocals of each other. Vertical lines and horizontal lines are perpendicular to each other because a vertical line has an undefined slope, so it was some number divided by 0, and a horizontal line is 0 divided by some number. Are those reciprocals of each other?
Yeah.
Yeah, so they're perpendicular. That's why horizontal and vertical lines are perpendicular. Okay, questions on that?
No, sir.
So if I gave you this slope of 2/3, what would be the opposite reciprocal of that?
3/2.
Not 3/2, but negative
Oh, yeah.
3/2. So the perpendicular slope, the slope of the perpendicular line, notice how I did the little M for slope and the perpendicular symbol, saying the perpendicular slope is negative 3/2. So if this is a slope of one line, the slope of the line that's perpendicular to it will be negative 3/2. It has to be the opposite sign and the reciprocal. So what would be the opposite reciprocal of -4?
+4.
It'd be positive, but what's -4 secretly over?
Oh.
So what's the perpendicular slope? 1/4. You have to, yeah, because you have to do 1/4. Great question. That's why. What's up?
Why do you need the M and under T?
Great question. So I'm just saying, hey, M is a slope, right? So I'm just telling us this is a slope, but it's the perpendicular slope. So this is my original slope, -4. The slope of the perpendicular line, the perpendicular slope, hence the perpendicular symbol, is 1/4. So it's just a way to quick clarify, hey, this is what it is. Just kind of like I did the parallel slope up here. Okay? What would our if the slope is 1, what would be the
-1 over -1.
-1?
Oh, yeah.
But yeah, if you put 1/1 and -1/1, isn't that the same thing as -1?
Yeah.
So you could write -1/1, or you could write -1. Either one's okay, right? Because they're the same thing.
Yeah.
That makes sense?
Yeah.
Questions on that? Give me a thumbs up if that makes sense. Give me a thumbs down if you're still struggling with it a little bit. Okay, thank you. Okay? Aiden, what part are you struggling with? Okay, do you understand how 2/3 and -3/2 are opposite reciprocals?
Yeah.
Okay, do you understand how these are opposite reciprocals?
Oh, yeah.
Do you understand how these are opposite reciprocals? Okay, is there anything on this page that you don't understand? Okay,
I have a question.
yes. I have an answer. Let's see if they match up.
What do you do if someone asks you to hold up?
Penguins. Oh, darn it. The answer didn't line up with the question. Sorry, I wasn't prepared for that. What if I do if somebody asks me to hold up?
Yeah.
I'm holding it up. No, this is holding on. This is holding up.
Okay, hold
You're
up.
holding up the
Whole
camera.
time.
Hold him.
Hold up the whole class. You won't.
I can't hold you all up.
How do you like the new?
Keep on what?
The new whip.
Leave me my bobber. What's that?
What?
New whip.
What about, how am I liking it? I'm liking it quite a bit. So it's a little bit extra work to get my lessons made in this because I already have them all made on my computer for the Promethean board. Because I've done that before. But now I'm having to kind of like remake them in here. And so it takes a little bit of work and I have to remember to do it. But otherwise I'm kind of liking it. It's been a pretty big convenience. How are you guys liking it? I'm more concerned with that.
I love it.
You love it?
Yeah, if we could have one.
Okay. Oh, okay. What do you guys like about it?
That you don't have to stand in front of our way.
Okay.
Organized.
Okay, I don't say far away. It seems more organized.
Yeah.
Tucker?
I would give a suggestion. That'd be kind of cool if, like, we could get something kind of like that. So, like, if we don't want to go, we could just write our answers.
Yeah. What I would love to do if we didn't have the Rona is actually pass you guys my iPad and have you guys write it up there. Right? Wouldn't that be nice?
Yeah.
That'd be cool. That'd be what's up. Okay? Anyone else having any feedback on the iPad so far? Does that kind of keep your attention a bit?
Yeah.
Okay.
You're not standing in someone that's standing.
One day you
Yeah.
just sit at your desk and talk.
I feel like that'd be awkward.
It would. Yeah.
Yeah, it would be very awkward. All right. Continuing on. Graph the line through -6, 2 that is perpendicular to the line with an equation of 3/2x plus 8. Wait, what's different about this versus the problems we had earlier?
It's perpendicular.
It's perpendicular right now. Bam! Nailed it, Lainey.
Yes.
Okay. So, what's our first step going to be, though?
You graph the point.
Graph the point, -6, 2. We want it to go through that point. We know that for sure. So let's graph that point. Okay, we know that's the thing. Right? We know that's the thing. We know that's the thing. Okay? Now, we need the slope of this line because we need it to be the pair perpendicular to the given equation. Why do we need the slope of this line? Of that line? Why do we need the slope of y equals 3 over 2x plus 8? What are we going to do with that slope once we get it? We're going to flip it and do the opposite, right? So what's the slope of this line?
3 over 2.
3 over 2. So what's the slope of my perpendicular line?
-2.
2 over 3.
Negative 2 over 3. This one was nice and easy for us to get the slope because it was already solved for y, right? So now where can I go from my original point, negative 6, 2? Up?
Down to.
Okay, down 2.
Right.
And right 3. Okay, where else could I go if I went up 2? If I went up 2, where would I have to go, left or right?
Right.
Left 3. Okay? Questions on that? Now for grins and giggles, I am going to quick graph this point, this other line. Okay? If I go to 8 and 3 over 2, down 3, left 2 would be the same thing. Or up 3, right 2. I'll do it again, down 3, left 2. I'll do it again, down 3, left 2. Yeah, I did left 1, excuse me, thank you. For grins and giggles, I'm graphing the given equation. Now, are we noticing that they are perpendicular?
Yeah.
Yeah, they are perpendicular. That is a right angle. So did we do it correctly?
Yeah.
Yeah, is that a way you can kind of check your work if you wanted to? Yes, you can. Do you have to graph that line? Definitely don't, okay?
Yes.
You don't have to graph it. It's not part of our answer,
No.
but you can.
Will we get extra points if we do it?
Nope.
Dang it. I wanted extra points though.
All right. So this was pretty similar to the problems we did before, right?
Yeah.
Except for now it's perpendicular, so we had to change the slope rather than use the same slope. So what do you think is going to happen on number 4? Probably the same thing, but now what do we have to do with our equation?
We have to pick
Get y by no.
Get y by itself. I want you guys to try it, and when you have it or have questions, raise your hand. Our first step is to graph that point, 2, 1, right? So I'm going to go 2 to the right, and I'm going to go 1 up. Now, I need the slope in order to find more points for my graph. I need the slope in order to find more points in my graph. I have 1, but now I need more. So I need to know the slope, but I know it's perpendicular to this line. So if I know the slope of that line, 2x minus 3y equals 3, can I find the slope of this line? Yeah, Tobin's saying, yeah, I agree. So do I know the slope of this line right now?
No.
No, I don't. So what do I need to do to find the slope of this line?
Get y by itself.
Get y by itself. So how do I get y by myself?
Negative 2, both sides.
Subtract 2x from both sides. Let's get that away from the y. So negative 3y equals negative 2x plus 3. Now what do I do? Divide by negative 3 on each and everything. Y is now equal to, what's negative 2x divided by negative 3? Well, positive 2x over 3. Very good. Minus 1. So we know this slope is what?
2 over 3.
2 over 3. So now we need our perpendicular slope. So our perpendicular slope is going to be
Negative 3 over 2.
negative 3 over 2. We make it the opposite sign. A positive becomes negative, and we reciprocate it. 3 over 2 from 2 over 3. So now from this point, what direction would I go 3?
Down 3.
Down 3. What direction would I go 2?
Right 2.
Right 2. It's a negative slope, so it needs to look like it's going downhill from left to right. Okay? So now, or I could also go up 3, left 2 for my original point. And I can connect these lines. My goodness. I can connect these lines and make my graph. As a way to make sure, if you wanted to, we could graph this original line. Y equals 2/3 x minus 1. Well, the b is negative 1. So I graph that, and then go up 2 to the right 3. Up 2 to the right 3. And does that look to be perpendicular?
Yes.
I'd say so. Okay. Once again, do we have to graph that in the blue?
No.
No, you don't have to. Just the purple one is our answer. Just the purple one is our answer, okay? So once again, what we did was we graphed our original point we were given, 2, 1. Then we had to find the slope of our other line that we were given, 2x minus 3y equals 3 by solving for y, and then make that the opposite reciprocal slope. Questions on that at all? Dope, okay? You send this up here, Maddie. You send it up there.
Yeah, I did
Okay.
it the wrong way.
Okay.
I did the blue way.
Ah, okay,
I did
okay.
the negative.
Gotcha. Okay, continuing on. Are these two lines parallel, perpendicular, or neither? Well, how would we know if they're parallel?
Make your own graph.
Okay, you can make your own graph, but what else would we know about the slopes if they're parallel?
They would be the same.
They'd be the same. So if they're the same, if these lines have the same slope, they'd be parallel. So are these first two lines, y equals negative 2x plus 6 and y equals 1/2 x plus 16, are those parallel?
No.
No, what's the slope of that first line?
Two.
What's the slope of the second line?
A half.
Okay, are they perpendicular?
Yes.
How do you know?
Because it's flipped.
Okay, it's flipped and it's what? Not only is it reciprocated, it's negative. So they're opposite reciprocals. So one's a negative and one's a positive. They need to be the opposite sign and reciprocated. So these two ones are perpendicular.
There's just a question
But why?
Because the slopes are opposite reciprocals.
Explain.
Oh,
Because it can.
okay. So slopes, very good. Thank you. I missed that. Slopes are opposite reciprocals. Okay? And you okay, buddy? Okay. So the slopes are opposite reciprocals, so they're perpendicular. Questions on that? Okay. On the second one, are we given the slopes? No. Was y by itself in either of those equations? Nope, we have to figure it out. We have to figure it out.
But
Okay.
why?
How about this? When you guys figure this one out, ask Mrs. Haswell or I to check it, and when you have it, you'll get the homework for today.
Oh, why you do that to me?
Okay? So when you have this correct,
Oh no.
you'll get the homework for today. So ask Mrs. Haswell or I if you need help or to get it checked.
Can I